Thus far in our journey into logic, we have been primarily occupied with learning what is an argument. What does a group of sentences have to possess? What do they have to have in order to be qualified as being an argument? We have already seen how this group of sentences does qualify as being an argument, while this one does not. So now that we're left with this group of sentences being an argument, we still don't know how strong of an argument it is. We don't yet know if we should believe it, if we should be a little hesitant in accepting the conclusion. All we know is this qualifies as being an argument. Now we turn our attention to part 2 of this series, and that is focused on determining each argument's individual strength. You can also apply these rules to a collection of arguments in the same way that we are going to do with just this one as well. There are 2 categories that are related, although technically different from each other, that we will consider. The first question is it valid? Question of validity. The second is it sound? Here are some working definitions for us to use. The first is the test of validity. Assuming the premises are true, then the conclusion has to be true. What is this saying? In this case, we are going to assume that each particular premise and the conclusion is true to determine if that makes the conclusion absolutely true, if it logically demands that the conclusion is true. So for one example, let's say that you have one apple, or let's say, let's say the argument is this: if I have one apple and if I add another apple, then logically how many apples do I have? This is a helpful way to see the logical demands that must be met in order for an argument to be valid. Because if we were to answer this with something other than true, or excuse me, two, then, for example, if the argument was, if I have one apple, if I'm going to draw a terrible apple over here, and if I have 2 apples, then I have, let's say, 2 peacocks. Well, it's still possible I have 2 peacocks. It's actually possible that I have 1,000,000 peacocks, or that I have 0 peacocks, but this particular answer isn't logically demanded by consequence of me having one apple and then adding another apple to it. So in this particular case, assuming each of these statements is true, is this conclusion, therefore, does it have to be true? Is it demanded that it has to be true? Well, let's look at it. Either Michael Scott is an idiot or a genius. So we are assuming that he is either a genius, he is either a genius or he is an idiot. We are assuming that is a fact. The next premise is Michael Scott is not an idiot. So we are also now assuming that Michael Scott, for a fact, is not an idiot. Now, the conclusion is saying, therefore, Michael Scott is a genius. We are assuming that, for a fact, Michael Scott is a genius. So our question is, if Michael Scott is a genius for a fact, is it logically correct to deduce this from the logical flow of these 2 premises? In this case, yes, it does. If Michael Scott, for a fact, is either an idiot or if he is a genius, if one of these 2 categories is absolutely true, and he is not this category, if he is not an idiot, then it's left that he has to be a genius. Therefore, Michael Scott is a genius. So it does logically follow that if Michael Scott is an idiot, and if he is a genius, that he is not the first category, but he is the second, then it does follow that he remains a genius. So this particular group of sentences does qualify the test of validity. Now we are going to look at its soundness. In this case, if the argument is valid, so if this test over here is passed, are the premises actually true? Here is a substantial difference between what these tests are really looking at. The first is saying, okay, if we assume for the sake of argument that your premises are true, does your conclusion logically follow from your premises? The second test is now focusing on the actual premises themselves. Are they actually true? We are no longer assuming, we are now determining whether or not the conclusion can in reality rest on the strength of the premises. So in this particular case, we need to know which Michael Scott this is referencing. In this case, this is focused on the fictional character in the Office romantic comedy series, and interestingly, an argument could be made for either of these. I don't want to get into that at the moment. However, in terms of the overall perspective being advocated by the series and through commentary of the directors and even the actor who played Michael Scott, we are going to, and I'm actually asserting an argument right now, we are going to take those at face value, and we are going to then, through that research, apply that to this argument. So either Michael Scott is an idiot or he is a genius. We know that Michael Scott, that fictional character, is an idiot. So this is still true. We haven't, this premise hasn't said that he is an idiot or a genius, or it actually did say that, but it's not choosing for us. It's not determining that he is an idiot or a genius. So we're okay at this point. The second statement now says Michael Scott is not an idiot. Well, we actually know that he is an idiot. So this particular premise is not true. We know that he is an idiot. So the conclusion, therefore Michael Scott is a genius, well, that's now wrong. So in this particular argument, it is valid because we assumed that the truth value of each sentence is true to see if it logically follows, so it's valid. However, it is not sound because the second premise says that he's not an idiot when he is. And so if he actually is an idiot, then he's not a genius. If, again, we assume that either means that these are mutually exclusive categories. And so in this particular case, this set of statements, even though it is an argument, even though it is a valid argument, it is not a sound argument.